This video covers the material that will be on the second exam in SOCY201 coming up in the next couple of days. You'll notice from this slide that the exam has 6 major questions attached to it, although some of the questions have sub-questions, kind of parts A, part B, and so forth. The exam is worth a total of 41 points, which is fewer than the first exam. And the questions in order will cover confidence intervals and interpretation, difference of two means and hypothesis testing, confidence interval for a proportion, comparing a sample mean to a population mean, and finally analysis of variance. You can see the point totals on the right side of the screen, and hopefully they add up to 41. Let's go ahead and look at some of the material that we need to cover for the entire exam, and then look at each question individually. You should definitely go back over your notes on hypothesis testing and understand that hypothesis testing provides a framework for understanding the world. And what we're going to be doing with hypothesis testing for a difference of means or difference of proportions test is asking the question, if we observe a difference, do we conclude that that difference is real or that it's due to some kind of error, like random error or sampling error or chance? Remember that there's 5 steps to hypothesis testing. You should definitely go back to your notes and check about remember how to create null and alternative hypotheses. What are the different sampling distributions we've learned so far as Z, T, and F? The difference between a 1- and 2-tailed test and how much evidence we need to reject the null. That is the alpha value. How to calculate the individual test statistics, and I'll share the formulas for the exam with you in a minute. And then how to make a decision about whether whether the null hypothesis should be rejected or not, and how to interpret that decision that you make. Within hypothesis testing, understand that there's 2 kinds of mistakes you can make. You should definitely review the material on type 1 and type 2 errors and understand the difference between them. You should also understand that the probability of making a type 1 error is equal to alpha, which is a value that is typically controlled by the researcher, and that the probability of a type 2 error, while related to a probability of a type 1 error, is determined by factors that we don't have full information about, and so we're not in a position to come up with the probability of making a type 2 error. We know the probability of making a type 1 error, and that's alpha. So let's move on to question number 1. Question number 1 is a single sample confidence interval. So we're going to go ahead and give you some summary statistics about a variable. We'll give you an average, and we'll give you a standard deviation and a sample size. And we're going to ask you to calculate and interpret a confidence interval around that average. You can see the formula down in the lower right. The trick here is to know how to calculate the standard error, that's sigma hat sub y bar. And I've shown the formula for a sample, which is S sub y divided by the square root of n. If you know those things, the calculation is relatively easy. Just follow this formula. The interpretation is more difficult. Please go back to your notes and the lecture videos and any other resources you have to understand that we're not 95% confident, for example, that our interval actually captures the population mean, but that our confidence lies in the process by which, in the central limits theorem, in the process by which samples are generated. That is, 95% of all samples we could take of a particular size will capture the population mean. It's an important but subtle distinction. Question number 2 is a difference of two means questions. Remember that for doing a difference of two means, specifically you need 6 pieces of information. You're going to have a sample that's divided into 2 groups. For example, you might have men and women. So I'm suggesting here we might give you something like average occupational prestige for men and women. 6 pieces of information: the mean for men, standard deviation for men, and the number of men. You also need the mean of women, the standard deviation for the women, and the number of women. With those 6 pieces of information, you can simply plug them into the formula that I'm showing here and calculate your difference of means t-test. This is step 4 in the hypothesis testing process. We're going to ask you to calculate this difference of means and then to interpret it. And remember, when we talk about interpretation, we're looking for information about 3 factors. We're looking at something for statistical significance, for direction, and for the magnitude of the difference. Finally, this question is going to ask you to look at the question that we've given you, and in the context of the question, whether it's occupational prestige or some other measure, to discuss what it means to make a type 1 error and to discuss what it means to make a type 2 error. Question number 3. Question number 3 is very similar to question number 1. We're going to ask you to calculate a confidence interval for a proportion. So we'll give you a proportion and a sample size. And again, you can see the formula at the bottom where the trick here is to calculate the correct standard error, which is the square root of p times 1 minus p divided by n. And then simply plug it into our normal confidence interval formula, which is some test statistic, some average, in this case p, plus or minus a t-score times the standard error. Like problem number 1, you need to calculate this particular confidence interval and then interpret it. And remember that the interpretation is a bit subtle and requires you to think about the probability that this sample, that this confidence interval around this sample proportion captures the population parameter versus all the possible samples you could take. Question number 4. So we talked about some, in the lecture notes, this was under the heading of some kind of sort of funny problems. And I indicated they were funny problems because we typically don't have the population mean. But in this problem we're going to assume that we do. And what we're going to give you is a population mean, a sample mean, and a sample standard deviation, and a sample size. And with that information, we're going to ask you to test and see whether the difference between the sample mean and the population mean is statistically significant. So, for example, if the occupational prestige in the population is 44 and it has a standard deviation of 14, if you had a sample with 100 people that had an average prestige of 50, is that 50 statistically significantly greater than the 44? You'd go ahead and calculate a t-statistic with this. We know it's not z because we don't have the population standard deviation, in which case we could calculate a z-statistic, but we know that t is similar and is mathematically related to it, so we'll calculate t and make a decision about how large that difference is. You need to use the t-table and make certain you understand how to use that t-table. Notice here that I have a relatively large sample of size 100. Question number 5 is identical to question number 4. The only difference is the sample size. So instead of having a sample of size 10, we have a sample of size 100. And this question is going to ask you to do the same thing that the question before did, but we're also going to ask you why the difference in these two test statistics. And my major hint here is to understand and go back and review how sample size affects your standard error and how the size of the standard error affects the size of t. If you understand those concepts, you'll be able to answer this question fairly easily. The last question on the exam is an analysis of variance problem. We're not going to have you do any calculations to calculate the sums of squares or mean squares for this particular problem. We're going to give you some computer-generated output, but we're going to leave some places in the table blank. Let's go ahead and look at an ANOVA table. This graphic is right out of your lecture notes, and it has all the formulas. But again, you're not going to need these formulas for the exam, but it's just to remind you that our first column is the sum of squares, and the sum of squares are additive. That is, SS between plus SS within is equal to SS total. That second column, labeled DF for degrees of freedom, is additive as well. So we know that J minus 1 plus N minus J is equal to N minus 1. The next column, labeled MS, stands for mean square. If we take the sum of squares between and divide by its degrees of freedom, J minus 1, we calculate MS between. That is, SS between divided by its degrees of freedom is MS between. We can also calculate the MS within, and that's the sum of squares within divided by its degrees of freedom, N minus J. So the relationship going from the first two columns, the sums of squares and degrees of freedom, to the mean squares is we simply take the sum of squares divided by the degrees of freedom to get the mean square. Finally, the statistic that we're most interested in is the F statistic, which is the ratio of those two mean squares. Again, your computer output, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 cells in this table that contain numbers, and we're going to give you a table that's missing 4 numbers, and based on the remaining information, using either addition, subtraction, division, or multiplication, you're going to determine the other numbers. The number we're actually interested in is the F calculated, or the ratio of the mean square between to the mean square within. The last part of this problem is that we're going to ask you to compare the F calculated from this table that you're going to complete with the F critical. And that means you need to go to use the F table. So you need to know how to pick out the appropriate F table for an alpha value of 0.05, 0.01, or 0.001. You need to know the degrees of freedom from your ANOVA table and how to use them to enter that table to find your F critical value. And finally, you should understand that you're going to make a decision based on comparing F calculated to F critical. And it's a pretty easy decision to make if your F critical is, let me say it the other way, if your F calculated is greater than F critical, you're going to reject the null. Otherwise, you're going to fail to reject the null. If you have any other questions, please feel free to contact me or your TAs, and we'll do our best to get you an answer to help prepare you for this exam.